our chapter, for chapter 2, aldehyde and ketone 2, we want to focus the nucleophilic addition on carbonyl group, C double bond O. Okay, from this chapter, you must able to understand first reactivity of carbonyl group, nucleophilic addition, followed by cyanohydrin formation and some of the addition of nucleophile, and the role is by using the nucleophilic addition. So the first, for this chapter, the most important rules, you must know the nucleophilic addition. What is the nucleophile addition? Okay, here is the nucleophilic addition. So we know that aldehyde and ketone containing of C double bond O, which is this part is very important to reactivity to occur. Okay, so because of this carbon center containing of high density positive charge, so that's why any kind of nucleophilic, is it strong, either strong or weak nucleophile, need to attack this carbon, because this carbon contain of positive charge. Negative attack to positive charge on carbon atom. Okay, to produce this end product. Okay, here we can see that this nucleophile, is it either the nucleophile is strong or weak nucleophile. So negative charge will attack this carbon, which is containing of high density charge, positive charge, so that this aldehyde and ketone will produce the intermediate product. Okay, here is the nucleophilic addition. Okay, I want to explain, elaborate and more detail on the nucleophilic addition, because of this is a very important part in mechanism. So we must know what is the right time to use the strong nucleophile and weak nucleophile, because both of nucleophile will give the different of product. Okay, in nucleophilic addition, you must know there are two types. First, addition by strong nucleophile such as hydride or Grignard reagent. So result, the product should be in tetrahedral, which is tetrahedral from the alkoxide intermediate. Okay, the most part aldehyde or ketone must be containing of carbonyl pi electron, so that the electron will shift to the oxygen and give the intermediate product, we call it as alkoxide. For strong nucleophile, only strong nucleophile produce the alkoxide intermediate. Okay, as you can see here, okay, this is the basic mechanism for nucleophilic addition. Means that we want to add nucleophile in starting material. Okay, this is our starting material, aldehyde or ketone, and can react with nucleophile, either strong. For this case, we want to discuss about strong nucleophile. Okay, so this strong nucleophile will attack this carbon contain of positive charge, and electron, pi electron, will shift to the O and will give O minus. Okay, the O become minus, negative charge. Okay, so now the nucleophiles can remain at carbon center and O become minus, and we call as this is alkoxide intermediate. This is alkoxide intermediate, CO minus, we call as alkoxide. Okay, so this is for first step. Second step is we want to protonate this O minus by using the HNU, and then this O will abstract or protonate this hydrogen proton, will to give the end product in tetrahedral geometrical. Okay, number 2, we're using the acid catalyst to facilitate the reaction because of the weak nucleophile. So the carbonyl group need a strong nucleophile. So that's why we use some of the acid catalyst to facilitate or to generate the reaction more effectively. So here there are two steps. Okay, first step, in this step, electron pair of the carbonyl oxygen, this C double bond O, okay, lone pair from the carbonyl oxygen accept proton from the acid, okay, from the acid to produce ozonium cation. For the strong nucleophile, produce when the nucleophile attack on static material, so produce alkoxide intermediate. But for the weak nucleophile attack to the the static material lone pair for C double bond O accept proton, okay, from the acid catalyst and produce ozonium cation. Okay, so this ozonium cation is more susceptible to nucleophilic attack. Okay, dalam keadaan ozonium cation, so nucleophile tu lagi senang attack the carbonyl of the static ketone. Okay, maksud kat sini, the function of the acid catalyst to facilitate the reaction to produce ozonium cation. So once you get the ozonium cation, so it's more susceptible to nucleophile tu untuk attack on C carbon center. Okay, so once you get the ozonium cation, so proceed for step 2, which is nucleophile can attack this carbon. Okay, can attack this carbon, so electron akan move. Okay, ozonium cation accept electron pair for nucleophile. Okay, then base remove a proton from the base, will remove the proton from the positively charged atom, so to generate the acid. So here is the mechanism for weak nucleophile. It's different from the previous. This is a mechanism for strong nucleophile. Okay, so now for aldehyde versus ketone. Okay, I want to explain the relative reactivity aldehyde and ketone. For your information, aldehyde is more reactive compared to ketone, okay, towards the nucleophilic addition. Why? Because of aldehyde contain more electron deficient, because they have only one electron donating alkyl group attached on the carbonyl carbon. Okay, because aldehyde we know that R C double bond O H, so only one alkyl group attached on the C. Okay, compared to the ketone. Ketone there are two alkyl attached on the C double bond O, so it's like more bulky compared to aldehyde. Aldehyde only one alkyl, ketone there are two alkyl, so the carbonyl surrounding the carbonyl is bulky. So that's why ketone is less reactive compared to aldehyde, but the reaction still can occur with two static material, aldehyde and ketone, but aldehyde is more reactive. Okay, if we can see here, this is aldehyde. What I said before, this is alkyl group and the other side is hydrogen. Okay, carbonyl carbon is more positive. Okay, more electrophilic because of only one R attached on C carbonyl. Okay, so easy to nucleophile attack on this C double bond O because less crowded. Okay, less crowded, only one alkyl group, and the other side there are only one hydrogen. Okay, so this is in intermediate alkoxide. Okay, when you get the alkoxide means that the nucleophile yang kita guna adalah strong nucleophile. Okay, proceed for step 2, which is we want to neutralize this negative charge on oxygen. So we abstract this proton to attract at the O minus to give the end product. alcohol. Okay, so now look at this one. For ketone, we know that the ketone is less reactive towards the nucleophilic addition. Okay, dalam mechanism nucleophilic addition, so they involve aldehyde ketone. In reaction, okay, nucleophilic addition, they prefer to reaction to lebih reaktif dengan aldehyde compare dengan ketone. Okay, because of reason dia satu, first because of there are two alkyl group, so the steric effect is very strong, and more electron donating or electron releasing group, so making the C double bond O less electrophilic. Okay, we can look here. Ketone, there are two alkyl group. Okay, so less positive, so the carbon C double bond O become less positive. Okay, because of the surrounding tu penuh dengan alkyl group, so this alcohol site look more crowded. Okay, so you can get the product in bulky form. Okay, so effect benzene on the reactivity of aldehyde or ketone towards the nucleophilic addition. Okay, first, the presence of benzene ring. Before this, I explained only the simple aldehyde and ketone. Okay, so now I want to explain if aldehyde and ketone attach with the benzene ring. So what happened to the C double bond O? Is it reactive or not? Okay, as we know that aldehyde is more reactive compared to ketone. So what happened if both of starting material attach dengan benzene? So dia akan jadi become less reactive. Why? So reason because of electron donating resonance effects. C double bond O akan jadi less electrophilic. Less electrophilic because of this aromatic. Electron in the aromatic dia akan aromatize. Aromatize means that the resonant. So electron tu berada di dalam this aromatic. So dia buatkan C double bond O akan less electrophilic. Okay, so next, look at the first reaction, which is involve the nucleophilic addition. Okay, you must be clear. Nucleophilic addition means that we want to add nucleophile on our starting material to get the end product. Okay, first, cyanohydrin formation. We want to form cyanohydrin. Okay, so aldehyde ketone react. Aldehyde and ketone in general react with HCN. So product yang akan dapat must be cyanohydrin. Okay, so this cyanohydrin actually functional group in organic compound, which is a cyano and hydroxy group attached to the same carbon atom. Okay, look here, this is a general chemistry. Aldehyde or ketone. Okay, focus on C double bond O. Okay, we want to add this nucleophile. Okay, concept rules gunakan nucleophilic addition. Why? Because we want to add this nucleophile on the C double bond O. So react with HCN because we want to prepare cyanohydrin. So kita mesti gunakan nucleophile HCN. Okay, so end product you will get the cyanohydrin, which is at C atom attached by two functional group hydroxy with cyanide. Okay, so there are some of example. This is for a aldehyde and this one is ketone. Okay, please stop for this slide. Okay, focus on mechanism of the addition of hydrogen cyanide. So means that we want to add CN on C double bond O. Okay, first step, okay, we want to add cyanide. Okay, for this example, ketone. Okay, react with the strong nucleophile CN. Okay, HCN. So nucleophilic Cn minus. So C double bond O is electrophilic. Because of there are 2 R, so this one is less electrophilic. So this one is strong nucleophilic. So this strong nucleophilic will attack this carbon. Okay, so pi electron will move to the oxygen. So you can get here intermediate in alkoxide form. Okay, you get the alkoxide intermediate because of CO minus. We call it as alkoxide intermediate. Okay, next, once you dapat alkoxide intermediate, next step apa dia? Kita nak neutralize this negative charge O minus with by protonate the HCN. Okay, we want to protonate or we want to abstract the hydrogen, proton hydrogen to the O minus. Okay, so minus protonate dia akan ambil proton hydrogen ni, kemudian CN ni akan jadi side product minus. So yang ini become end product cyanohydrin. So this one is mechanism of nucleophilic addition. Nucleophile add or attack on C and dia akan remain dekat C. CN akan remain dekat C. Okay. The cyano group can be hydrolyzed or reduced. Okay, so ada 2 kat sini untuk cyanohydrin formation. Okay, first hydrolyze of cyanohydrin, so produce α-hydroxy carboxylic acid. Okay, number 2 reduction cyanohydric product, so produce alpha beta amino alcohol, or we call it as α-hydroxy aldehyde. Okay, look at the first hydrolysis of cyanohydrin. From the previous we get cyanohydrin product from aldehyde and ketone or ketone. Okay, we get the cyanohydrin. So now from cyanohydrin form, we hydrolyze by using water and strong acid HCl to produce alpha-hydroxy carboxylic acid. Okay, alpha-hydroxy, this one is alpha carbon because this alpha carbon attached with OH attached on the alpha carbon, and this one is carboxylic acid. So you get the end product alpha-hydroxy carboxylic acid. While for the reduction of cyanohydrin, okay, reduction of cyanohydrin ada 2. First, kita gunakan reducing hydrogen with nickel, or kita gunakan strong reducing agent lithium aluminium hydride /H2O. So we'll give the product alpha beta amino alcohol. Okay, but once you using the debal, which is debal is a very weak reducing agent. So the end product of cyanohydrin, you can get the alpha-hydroxy aldehyde. This one is alpha-hydroxy aldehyde. Why alpha carbon? Because of this carbon is near to the substituent. Okay, so this is the example of hydrolysis of cyanohydrin. Okay, first step must be step for nucleophilic addition. Okay, before you dapat cyanohydrin, mesti from starting material aldehyde or ketone. So for this case, dia guna ketone, and then react dengan react with the hydrogen cyanide. Okay, strong nucleophile. Ingat nucleophilic addition, kalau strong nucleophile, so this CN negative nucleophile, dia akan attack to the electrophilic kat sini C positive, so dia akan remain kat sini CN on carbon atom. And then before you get this cyanohydrin, mestilah dia jadi dalam keadaan alkoxide intermediate. Okay, O minus, and then protonate, barulah you akan dapat this one hydroxy CN on the same carbon. Okay, so once you proceed hydrolysis, okay, by using the HCl and H2O, you will get the alpha-hydroxy acid. Okay, and for this one, if you continues from the cyanohydrin and then heat by H2SO4, so you will get the alpha beta unsaturated acid. Okay, so this one is the example reduction of cyanohydrin. Okay, by using the ketone, react with the HCN, and then you will get the alkoxide intermediate. After alkoxide intermediate, protonate proton to get end product of this one, cyanohydrin. Okay, cyanohydrin, once you nak reduce, dia ada dua. Kalau you guna strong reducing agent, lithium aluminium hydride, you akan dapat this one product. And if you using the dibal as the weak reducing agent, so you can get this end product.